Good afternoon. So we are starting with another topic, primitive flower. Concerning the most primitive living angiosperm, there has been two views. First one is called a Englerian school, where Engler, or in that concept, it is considered that Amandiferae, particularly Casuarinaceae, is the most primitive among typhoid. And the second concept is the Bessian school, were bisexual flowers of magnolias to be the most primitive. So there are two concepts regarding the primitive flower. Englerian school, where Casuarinaceae is considered as the primitive one, whereas in Bessian school, bisexual flowers of magnoliaceae is the primitive one. And during the last few years, the paleo herbs are emerging as a strong contenders. And the candidates belongs to the basal groups. So there are some basal groups among angiosperms. They are discussing below. First one is the concept of a primitive flower as per Englerian school. We say in Englerian school, or in that concept, Casuarinaceae is considered as a primitive flower. So according to the Englerian school, the view now which is largely rejected. Even though they considered it is an primitive, it is highly rejected. And the Amandiferae with reduced unisexual flowers in catkins constitute the most primitive living angiosperm. Engler as well as Rendell and Wettstein considered Casuarinaceae to be the most primitive. So Englerian school considered Amandiferae as the primitive, which has reduced the unisexual flowers. And addition to this, Engler, Rendell and Wettstein considered Casuarinaceae is the primitive one. That is the first concept, but it is rejected. And the second one is the Bessian school, where we said magnolias are the primitive. So alternatively, Bessian school considered the Rennelian complex, that is the magnolias, having bisexual flowers with free, equal, spiral arranged floral parts representative of the most primitive angiosperm. So Magnoliaceae or the Michaelia or Magnolia, we know the flower. It has numerous floral organs which are spirally arranged, large flowers. So these are considered as the primitive flower. So there are few families. First one is the Magnoliaceae. Bessie, Hutchinson, Tuctagen and Cronquist all believe that large solitary flower of Magnolia with an elongated floral axis bearing numerous spirally arranged stamens and carpels is the most primitive living representative. The stamens of Magnolia and other closely related genera are laminar, perianth is undifferentiated and pollen grains are monosulcate and boat-shaped. In the subsequent works, however, Tuctagen agreed that the flower of Magnolia is more advanced than those found in Winteraceae and Degeneraceae. So, Bessie, Hutchinson, Tuctagen and Cronquist considered Magnoliaceae or the flowers of Magnolia are primitive. But later, Tuctagen considered that Magnolia is advanced than Winteraceae and Degeneraceae. So, we have to check what is the condition of Winteraceae and Degeneraceae. Winteraceae is the Gottsberger and Thorn considered the most primitive flower to have been middle-sized with fewer stamens and carpels and grouped in lateral clusters in the family Winteraceae. So contrast to the Magnoliaceae here, it is a middle-sized, whereas in Magnoliaceae it is a large flower. Here it is middle-sized with fewer stamens and carpels. In Magnoliaceae it is numerous. Here the number of stamens and carpels are fewer and grouped in lateral clusters. Example, dryness. This view is supported by the occurrence of similar stamens and carpels, absence of vessel, morphology similar to pteridosperms, high chromosome number suggesting a long evolutionary history and less specialized to little pollination of dryness compared to the magnolia. So when considering the features of dryness, it is much primitive than magnolia. And the second family is Degeneraceae, that is Cartesian considered it is the most primitive. Degeneraceae may be recognized by their spiral, entire exstipulate leaves and large axillary flowers with many tepals and a single carpel. Vessel elements have scalariform perforations, leaves are spirally arranged and pollens are boat-shaped. The most significant plesiomorphic or the primitive feature including stigma running on entire length of the carpel and lamina stamen with 3 veins and the fruit, a follicle and embryo with 3 to 4 cotyledon. So, 3 families are, as per Bayesian school, 3 families are considered to be more primitive: Magnoliaceae, Winteraceae and Degeneraceae. So, altogether, we can define a primitive flower as they have simple, alternate, exstipulate leaves which are entire and petiolate with a poorly organized reticulate venation and with unilacunar tuberous nodes. The vessels are absent or brachiate-like. Flowers are bisexual, radially symmetrical with spirally arranged floral parts. Stamens are broad, undifferentiated with marginal microsporangia. Carpels are broad with a large number of ovules. Stigma along the margin and not completely sealed or fused. Ovules are bitegmic, quasi-nucleated and fruits are follicular. So these are the characteristic features of a primitive flower. And how a flower is formed? That is the ontogeny of a flower. The flowers are formed from the reproductive apex, which is formed from the vegetative apex under the activity of florigen. So florigen is the floral hormone. Due to the activity of florigen, from vegetative apex, reproductive apex is formed, and in that reproductive apex, a flower is developed. And during the juvenile phase, no production of florigen occurs. And the process of development of a flower is in acropetal manner. So from base to apex, that is the basal word, calyx, corolla, androecium and gynoecium. So from base to apex, the ontogeny is occupied, and in all angiosperms, the development of petal is delayed even though the development is acropetal. Stamens and staminode starts its development together, but staminode ceases its development at the middle. And the fusion within floral world or between floral worlds are neither congenital or postgenital. So these are the ontogeny or the sequence of floral or flower component development. And what are the basic evolutionary trends we can see in a flower? First one is regarding the fusion. During the course of evolution in angiosperms, fusion of different parts had led to floral complexity. In Magnoliaceae visi, there are floral parts which are numerous in number and they are free. Later, during the course of evolution, these floral parts undergo fusion and make the flower more complex. Stamens have shown fusion to different degrees. First, we say numerous stamen which are free in Magnoliaceae, in Winteraceae and Degeneraceae, and fusion of filaments only, that is the monadelphous condition, is seen in Malvaceae. Fusion of anthers only, that is a syngenesious condition, found in Asteraceae, or complete fusion, that is a synandry in Cucurbitaceae. So the stamens show different degrees of fusion during the course of development, course of evolution. Like that, carpels also show fusion. Fusion only by the ovaries, that is syn ovaries in Caryophyllaceae, only by the style, syn stylus in Apocynaceae, or complete fusion of both ovaries and stylus, that is syn stylovarius, that found in Solanaceae and Primulaceae. And fusion of unlike parts has resulted in an epipetalous condition. We know what is epipetalous condition. When the stamens attached or fused with the petals, it is called epipetalous condition. So here the fusion of unlike parts are occur. And like that, the gynostadia were the fusion of stamen and gynoecium found in Asclepiadaceae and formation of the inferior ovary. So these are the different trends of evolution when considering the fusion as a character. Second is the reduction. Reduction in the case of number of floral parts and the floral organs. So simple flowers of many families are formed as a resultant of reduction. The loss of either stamen or carpel has resulted in unisexual flowers. So we considered the primitive flower as a bisexual one, and by the reduction of either stamen or carpel from the bisexual flower, a unisexual flower is developed. And the loss of one perianth word has resulted in monochlamydous forms and their total absence in echlamydous forms. Like that, the individual reduction in the number of perianth parts, number of stamens and carpels are also seen in angiosperms. Within the ovary of different genera have shown reduction in the number of ovules to ultimately one. Like we can see similar condition in Ranungulaceae, where the transition of follicle into achene, or if we consider or examine the flowers or fruit of Ranungulaceae, we can see the transition of follicle to achene and reduction in size of flower. We know Magnoliaceae, where we consider it as a primitive family, has a large flower. Whereas in Asteraceae and Poaceae, which is considered to be the advanced, has a small size of flower. So the reduction in the number of floral organs, size, and their reduction in the size of seed also, where the size of seed has been extreme in Orchidaceae, or Orchidaceae has a very minute seeds. So the reduction in the size of seed has been extreme in Orchidaceae. And male flowers of Euphorbiaceae. We know the Euphorbiaceae in the male flowers are represented by single stamen. So it is represented by a single stamen, bearing no perianth or any trace of pistil oil. So that is the extreme condition of male flower, where every component is reduced and the male flower of Euphorbiaceae is represented by a single stamen. So this is the evolutionary trend seen with respect to the reduction. Third one is the evolution in change in symmetry. From simple radial symmetric actinomorphic flowers. So actinomorphy is the primitive one, radial symmetry is the primitive one, and from simple radial symmetrical actinomorphic flowers, zygomorphic flowers in various families are developed. And the size of corolla tube and orientation of corolla lobes changed according to the mouthpart of the pollinating insect, like that of salvia, where you can see this is the insect which is feed on the salvia flower, and for the orientation of, just look at the orientation of the corolla lobe. It is we can call it as a co-evolution. And like this, there is ophrys. It's a orchid, but this is the ophrys female flower. Sorry, this is the ophrys flower, and this is the wasp, which acts as a pollinator of ophrys. What the process occur here is the female wasp. This is the male wasp, and this is the ophrys flower, and the male wasp consider the ophrys flower as its mate or female organism, and for this male wasp reaching the ophrys flower and try for mating and causes the pollination of the ophrys. So here the ophis flower mimic the wasp, female wasp, and cause or resulting in the pollination of this orchid. And there is another term called remoration. This term was suggested by Melville. This refers to the evolutionary retrogression found in angiosperm and their fossil relatives. So remoration is the evolutionary retrogression. It is a retrogression found in angiosperms and their fossil relatives. Then the co-evolution of flowers with A-VIS pollinators. How a flower evolved, and when evolution occurred to a flower, similar kind of or co-evolution is occurred to a pollinator. Or if a evolution occurred to a pollinator, a co-evolution occurred to the flower. So there are some connection between the pollinators as well as flowers. Early seed plants, the gymnosperm were wind pollinated with a sticky sap. We know gymnosperms are wind pollinated. And early insects, that is the beetles, were probably attracted to the sap and pollen by chance. The better pollination and increased seed set encouraged the selection towards showy flowers more attractive to insects. അപ്പോൾ നോൺ ഷോയി ആയിട്ടുള്ള ഫ്ലവേഴ്സിനെക്കാളും ഇൻസെക്ട് അട്രാക്ട് ചെയ്യപ്പെടുന്നത് ഷോയി ഫ്ലവേഴ്സ് ആയിട്ടാണ്. സോ അപ്പം അവിടെ ഒരു എവല്യൂഷൻ നടക്കുകയാണ്. ഷോയി ഫ്ലവേഴ്സിൽ നിന്നും നോൺ ഷോയി ഫ്ലവേഴ്സിൽ നിന്നും ഷോയി ഫ്ലവേഴ്സിലോട്ട്. And increased visit by insect poses danger to the exposed seeds, resulting in selection towards protection of seeds in enclosed carpel, a major step towards the evolution of angiosperm. അടുത്തതൊരു എവല്യൂഷന്റെ പാർട്ടായിട്ട് നമ്മൾ പറയുന്നത് ഇപ്പൊ ജിംനോസ്പേം ആണെങ്കിൽ നമുക്ക് നേക്ഡ് സീഡ്സ് ആണ്. സപ്പോസ് ആൻ ഇൻസെക്ട് ഈസ് ഫ്രീക്വന്റ്ലി വിസിറ്റിംഗ് എ ജിംനോസ്പേം, ഇറ്റ് വിൽ കോസ് ഡാമേജ് ടു ദാറ്റ് സീഡ് ബിക്കോസ് ഇറ്റ് ഈസ് എക്സ്പോസ്ഡ്. അപ്പൊ ഫ്രീക്വന്റ് വിസിറ്റ് മൂലം അതിന്റെ സീഡ്സ് എക്സ്പോസ്ഡ് ആയതുകൊണ്ട് അതിന് ഡാമേജ് വരുന്നതിനെ തടയാൻ വേണ്ടിയാണ് ആ സീഡിന് ഒരു പ്രൊട്ടക്ഷൻ വരുന്നത്. ദാറ്റ് ഈസ് എ കോ എവല്യൂഷൻ ആൻഡ് എ പ്രൊട്ടക്റ്റഡ് സീഡ്. ദാറ്റ് ഈസ് the major step towards the evolution of angiosperm. And increased production of seed encouraged smaller seeds in increased number. അപ്പോൾ സീഡ് പ്രൊട്ടക്ട് ചെയ്തപ്പം ആ സീഡ്സിന്റെ അവിടെ അതിന്റെ സൈസിലും നമ്പറിലും ചേഞ്ച് വന്നു. സൈസ് ചെറുതായി, നമ്പർ കൂടി. And shorter life cycle to overcome drought conditions. So these are the co-evolution occur with respect to the pollinators. So complete closure of carpel was accompanied by the differentiation of stigmatic region for receiving pollen and the distinct style to keep the stigma with to reach the insect. So there are some pollination syndrome. We can see the pollination syndrome in this table, where you can see the animal features which as well as the co-evolved flower features. If a flower is bee pollinated, bee has color vision, good sense of smell and require nectar and pollen. So these are the characters of bee. So if a plant is pollinated by bees, it should have bright colors like blue, purple, yellow and white. Since the bees have a good sense of smell, the flower must be fragrant and the flower must provide nectar and abundant pollen as a reward. If a plant is pollinated by butterflies, where butterfly has good color vision, sense of order, need a landing place and feed with a long tubular tongue, then the flowers must have blue, purple, deep pink, orange, red colors, light floral scent or lightly scented flowers, provide landing place for the butterflies, and it should have nectar in deep, narrow floral tubes. If a flower is pollinated by birds like our hummingbirds, the birds have color vision, often require a perch with a poor sense of smell and feed in daytime. Usually the birds are feed in daytime with a high nectar requirement. So if bird have these characters, then our flower must have a colored one. Usually it is red with a strong